So, in my previous talk, I had mentioned the aspects of algebra in ancient Indian treatises, namely proto-algebra, which includes the geometric algebra of the Vedic time, the algebraic ideas in decimal system and arithmetic, and the high school algebra or classical algebra, so which where you have awareness that there is a distinct branch of mathematics. There is use of symbols, formation of equations, there is an extension of the number systems, and then there are identity, formulae, solutions of equations, etc. So, to understand Brahmagupta, how as a creator of algebra, let us also look at the algebra which was preceding Brahmagupta, which is not, does not fit the phrase algebra as we know it. So, there was a geometric algebra in the Sulva Sutras. So, I will illustrate it with two examples. So, draw a square n times a square of side A. So, your A is given and you have to draw a square n times that. So, area is A square, that means you have to draw a square whose area is n a square. That means you have to construct root n times A and you have to do it accurately, therefore, you cannot do it by measurement. You have to do it by what is now called the ruler and compass methods. So, Indians had an analog of that. So, this is the construction that you construct the base. Since you have A, you can construct any multiples of A. So, the base is n minus 1 times A, and then you have n plus 1 times A, which you can bisect, and so this is n minus 1 times A, and this is the half of n plus 1 times A. And then what the prescription is that the altitude will give you the required side. Another construction is that you have a rectangle whose smaller side is B and the bigger side is A, and you have to construct a square whose area is equal to the area of this rectangle. And Baudhayana of 800 BC, his prescription is that you look at this remainder, that is A minus B, bisect it. So, this whole thing becomes A plus B by 2. Then you have an arc, see where it meets this side extended. So, this part is A plus B by 2 and this part is A minus B by 2. And what Baudhayana says is that this gives you the length. Now, what you see, the features of the two examples is that you have exact construction of root n or root AB, in the first case root n, in the second case root AB, without any measurement or approximation using Baudhayana version of the Pythagoras theorem. And here you have the geometric expressions of the algebraic formulae. N a square is n plus 1 by 2 whole square s square minus n minus 1 by 2 square s square in the first case. And in the second case you have A b is a plus b by 2 whole square minus a minus b by 2 whole square. So, what you can say is that the formula, let us say this construction gives a geometric expression of the algebraic formula. A b is, this square is A b. So, A b is a plus b by 2 whole square minus a minus b by 2 whole square. So, this is geometric algebra. Now, let us move on to the next one. Oh, no, before that. So, though there is an awareness of algebraic formulae and quadratic equations in geometric form, identities and equations are yet to be formulated explicitly as algebraic expressions even formally. So, the science of algebra is at best dormant. So, this is not algebra as we know it. But here this is not to undermine the Vedic savants. Their greatness is that they invented mathematics algebraic in spirit and substance much before the genesis of formal algebra by Brahmagupta. So, that really shows that how powerful they were as mathematicians. Now, the founder of Bhaskaracharya Pratishthana, Abhyankar, has a poem mathematical poem which begins with the lines polynomials and power series, may they forever rule the world. So, I am quoting it just to say that polynomials and power series are at the heart of modern algebra and modern algebraic geometry. Now, you see the algebraic aspect of the decimal system. So, a polynomial of degree n can be represented as a n x to the power n plus etcetera, and you can also write them as just collect the coefficients a n, n minus 1 dot dot a 2, a 1, a 0. Now, if you write it in the first form, then you need not write the coefficient if it is 0, but if you write it in the second form, then you have to put 0. So, example 2x cube plus x square plus 7 is a polynomial, and if you write it as a tuple, it is 2107. And you see the analogy. A number is expressed in decimal system as 2107. That is analogous to the first one, and the other representation is 2107, which is analogous to the second one. So, the decimal place value system is, you can say, a form of 10-adic polynomial expansion. Now, this is not something that once polynomials have been invented that you are now linking it to decimal system. Polynomial, the decimal system is something which inspired the invention of polynomials. So, who in modern mathematics, modern Western mathematics is most strongly associated with polynomial and power series? That is Newton. Once in Calcutta, Abhyankar was saying that Newton with his polynomial and power series is the founder of everything in modern mathematics. Now, so what was Newton's inspiration? You see, the polynomial, power series, periodic expansions are conscious generalizations of the decimal system. So, Newton says that since the operation of computing in numbers and with variables are closely similar, I was amazed that it has occurred to no one to fit the doctrine recently established for decimal numbers. So, Newton's time is 1671, and 17th century is the time when decimal system finally became standard in Europe. That is why he says doctrine recently established for decimal numbers. So, especially since the way is then open to more striking consequence. For since this doctrine in species has the same relationship to algebra that the doctrine in decimal numbers has to common arithmetic, its operation of addition, subtraction, multiplication, division and root extraction may be easily learned from the latters. So, what he is saying is that the decimal system that we have learned recently, this tells you how to work with polynomials. You just copy the ideas given in the decimal system to polynomials and you get the polynomial algebra. So, once you see such phrases, you would not be surprised when I say that Brahmagupta gave the algebra of polynomials. Nothing shocking about it, because Brahmagupta grew up in the decimal system. So, these perspectives have to be kept in mind. An interesting thing is that even in the 20th century, so Abhyankar has a famous theorem called epimorphism theorem. So, he has something called Kyoto notes where he elaborates on the proof. So, there at one point he says the concept of a strict system of generators of a semigroup, which is a technical device which he is introducing, something which he called g-adic expansion, is a generalization of the idea of decimal expansion. So, even in 20th century, you can see decimal expansion inspiring new mathematical innovations. Look at the multiplication algorithm. That is also something algebraic. It uses distributive property of integers. It uses the polynomial-like aspects of integers expressed in decimal system. So, for just you look at what is 19 into 12. How do you do it? What you do is, you think of 19 into 12 as first as 19 into 2 plus 10, which is 19 into 2 plus 19 into 10. That distributive property is used to first calculate 19 into 2 and then 19 into 10 and then add up. And this add up is polynomial algebra addition. Or you look at the algorithm for square root, which was given by Aryabhatta in 500. So, that implicitly uses this formulae. That is why the algorithm works. Now, let us come to the use of symbols, which, as I said, that Brahmagupta was the pioneer, but what were the steps which went before that? So, first of all, use the Sanskrit alphabet itself follows. There are, of course, all languages have alphabets, but Sanskrit alphabet has the quality of following the phonetic principle, one sound, one symbol. So, the sound ka is represented only by this and not by sometimes c or sometimes k, and then c can be ka or it can be cha, nothing like that, one sound, one symbol. Panini's work has symbols and symbolic operations, not the mathematics thing, but there is the symbols and symbolic operations. Pingala has symbols, I mean he because it is an oral text, you do not know what that symbol is, but he is talking about using the symbols for Laghu and Guru as labels, which means that there were symbols. We do not know what that symbol is, but there were symbols. Decimal notation itself is something like the Sanskrit alphabet. Sanskrit alphabet is one sound, one symbol, and decimal notation is one digit, one symbol. Bakshali manuscript has symbols for arithmetic operations, which I will show you, and Aryabhata uses vowels as place values and consonants as digits to represent numbers in base 100. So, this is as far as use of symbols before Brahmagupta. And now, but what is the definition of algebra given by Dutta Singh? Symbols for unknowns. These are not symbols for unknowns. But unknowns started getting represented. There were terms for unknown. What? So, there is a Jaina text which uses yavat tavat for unknown. Aryabhata uses the term gulika. Brahmagupta uses avyakta, ishta, etc. as words. So, just to give you an idea about Aryabhata, how how he had driven the Indian mind towards algebra, and which came out during the time of Brahmagupta. So, what he does is that you look at the Sanskrit vowels, let them represent powers of 100. So, A represents 1, E represents 10 square, U represents 10 to the power 4, Re represents 10 to the power 6, and so on. And of course, you do not distinguish between long and short vowel, because when you pronounce a word, it is not clear whether you are pronouncing long and short. So, there is no distinction between that. Then the consonants, from ka to ma, there are 25 consonants. So, you represent it by 1 to 25 depending on where they occur. And then ya, ra, la, va, sha, sa, sa, ha, that you represent by 30, 40, 50, 60, 70, 80, 90, 100. So, this is very convenient for representing big numbers in astronomy. So, for example, ma means 25. But just say mu, u is 10 to the power 4, so that becomes 25 into 10 to the power 4. So, this is a very powerful use of the Sanskrit alphabet. So, letters of the alphabet are coming up. And then Bakshali. Bakshali manuscript is estimated to be 300, not the manuscript that is kept there, but the original one that is believed to be written in 200 or 300 AD. So, the Sanskrit term is yuti for addition, and Bakshali manuscript uses u, the first letter. Subtraction is kshay. So, ksha, now the ksha you have to also write it fast. So, the symbol used is plus, which is believed to be an abbreviation of ksha. Then division, bhaga. So, bha. Root, there is a typo here, it should be the first letter, mu. Just to give you a feel for the pages of the manuscript. So, this is taken by Castleman, Bill Castleman. So, this is what the Bakshali manuscript looks like. You can see U here. So, he gives also shows you. So, this is the manuscript, and then he helps you to understand what it represents. So then he has given what is what, 1, 1, 0, I mean all these things. Now we come back to Brahmagupta. So the foundation of algebra, the first thing, criterion was symbol for unknowns.
Kasselman is from Yale, right?
I can't recollect right now. So symbols for unknowns. Brahmagupta prescribes use of varna. What is the Sanskrit meaning of, what is the meaning of the Sanskrit word varna? It means letter of alphabet as well as color. So playing with this varna as symbols for different unknowns. So his commentator Prithu Goswami illustrates. So first word is not color, because there is already a term from the long time, yavat tavat. So the first letter is ya. So ya is that X. But if you have more unknowns, then start using colors. Kalaka. So ka. Ka is another symbol. Nilaka. So ni. Similarly, you now keep on character. Lohita, harita, etc., etc. Use the first letters. So you see, letters of the alphabet are used to denote unknowns, and what are the criteria? So what you do is that you denote the unknowns by colors and use the first letter of that color. And you can see that what are the ideas which would have gone into Brahmagupta's mind. He had read Aryabhata, of course, and Aryabhata had made a very powerful use of letters of the alphabet, and now how it got crystallized into the algebraic use of the letters of alphabet. Now here I would like to give a caveat regarding algebra. When you read history of algebra, it is based on Western history, and what they do is that history of algebra is classified as rhetorical algebra, where algebra is in words, then something called syncopated algebra, which means that basically in words, but some rudiment of symbols are there, and then finally symbolic algebra, what you know, ax squared plus bx plus c equal to 0. That classification is not applicable in Indian context, because what happens is that this has got firmly entrenched in the minds of everybody, and then when you see something, you try to immediately, so Brahmagupta, is it rhetorical, is it syncopated, it is symbolic, you think like that. The problem in with this is that we tend to think of only the masters like Aryabhata, Brahmagupta, Bhaskaracharya and their major texts. They are all written in slokas. Okay. So let us say quadratic equation, how the roots are written, they are written in words. That doesn't mean that it is rhetorical or syncopated algebra, because they are telling you how to do things in symbols. But when they write a text, when the masters write a text, it was the convention to say things in words. That exists even now. So in the research institutes, you have to write annual reports to be sent to the government of the work activities. When it comes to mathematics, there is an instruction, avoid symbols as much as possible. Write things in words. We don't write Rx1, x2, xn, we write polynomial algebra. I mean that is what, everything should be expressed in words. You talk about Fermat, how did he explain his questions? Look at his works, these are all expressed in words. So that was the convention, but when they do the work, they do it in symbols. So if you look at commentaries, that is where you will find symbols. Okay. So Brahmagupta's slokas, make no mistake, they are in words, not in symbols. And that leads them to be classified as that he belongs to an earlier phase of algebra. So don't make that mistake. So next was formation of equations. So there are already examples in Bakshali manuscript, but this is taught by Brahmagupta that there is a term for equation, and that is still there in Indian language. Samikaran is the term for equation. So Karan is doing, Sami is equal doing, equalizing. That is what equation is supposed to mean. Symbols for different unknowns is varna, term for coefficient is gunaka or gunakara, term for the visible portion of the equation, that means the known coefficients, that is rupa. Rupa is something which you can see. So 2x plus 3y plus 5, that 5 is rupa. and the to the power is called gata. So, how to write an equation? Let us say 10x minus 8 equal to x square plus 1. This is illustrated by his commentator Prithagadevaswamy. So, look at the left hand side, the coefficient of x square is 0. Now, how do you write x square? X is ya, yavat, tavat, abbreviation is ya, and square is varga. So, yava. So, yava is 0 on the left hand side and ya is 10 and the rupa is 8 with a dot at the top, indicating that it comes with a minus sign. And now, it is not written left hand side equal to right hand side, but it is written one below the other. So, the right hand side is yava is 1, ya is 0 and rupa is 1. So, this may not match our picture of an equation, but you see that this is really convenient, because if you when you process an equation, now you have to your 5 is written here and 3 is written there, but if it is written vertically, that becomes more convenient for checking it out. So, this was an interesting way of representing an equation. Then look at, so this was only in one variable, now look at a linear equation in several variables. So, 197x minus 1644y minus z equal to 6302, how will you represent it? So, the left hand side ya is 197, ka, kalaka, that is 1644 with a dot, ni for z, that is 1 with a dot, there is no rupa on the left hand side, and on the right hand side the ya, ka, ni, all the coefficients are 0 and rupa is 6302. So, this is how equations were represented. So, equations are prepared. So, there is so the term used for that was sama shodhana, that means clearance. So, you clear out this minus 8 and 1, you combine to make it x square minus 10x minus 9. Equations are classified by Brahmagupta. So, equation in one known is called Eka Varna Samikarana, which are of again two types, linear and quadratic. Quadratic is called Avyakta Varga Samikaran, Varga is square. Equation in several unknowns is called Aneka Varna Samikarana. Equation involving product of unknowns is called Bhavita. Then the algebra of polynomials is clearly stated here. So, it is as clear as it can be. So, for the unknowns, they are squares, cubes, fourth powers, fifth powers, sixth powers. Addition and subtraction are performed of the like. So, if you have 5x square and 6x square, and if you add them, add it 5 plus 6 x square. Of the unlike, stated severally. So, how do you add 5x and 6y? Just keep them separate. How better can you explain the algebra of polynomials in several variables? Now, the product of two like unknowns is a square. So, if you have 5x into 7x, you make it 5 into 7, x into x is x square. The product of 3 or more like unknowns is a power of that designation. So, x into x is x cube, x into x 5 times, that will be x to the power 5, etc. The product of different unknowns, so that has a term bhavitaka. So, x into y, just you keep it separate, x. Then what you do after taking product, how to add them? Like it has been stated before. So, how better you can represent the polynomial ring, the operations of addition, subtraction, multiplication of a polynomial ring in several variables. So, this is very clearly stated, the algebra of polynomials is very clearly stated by Brahmagupta. Now, I anticipated there will not be time for the number system. So, therefore, I will do it in my next talk, but I just because it is so foundational, I will just summarize, but I will give the details. That there is a separate section within that chapter Kutakadhyay on Dhana, Rina, Shunya, Sankalam, that is now combined treatment of positive, negative, 0. So, Brahmagupta was a dormant modern abstract algebraist who in retrospect envisaged integers as a ring with 0 as the identity. So, his text is the earliest use of 0 as an integer in algebra. Earliest use, so there is 0 as a place marker That is very ancient, and that occurred in several civilizations. But where it is unique to India and unique to Brahmagupta is use of 0 as an integer in algebra. All rules of operations with numbers positive, negative and 0, treating them all on the same footing, like minus into plus is minus, minus into minus is plus, a into 0 is 0. So, all this what exactly Brahmagupta has said I will give in details, because today there would not be time. So, further details about these negative numbers and 0 will be given in the next part. Now, so far what I have been saying was absolute rigorous. Now, I will just spend a couple of minutes on a bit of a speculation. This is purely speculative, it can neither be proved nor disproved. That what I am saying, what I am trying to question is that whether the mystic culture in India had helped prepare the Indian mind for the subject. Now, this thought came to me while reading The Secret of the Veda of Sri Aurobindo. Now, mind you, again, Sri Aurobindo is not discussing history of algebra, he is trying to explain what the Veda represents. So, when he is trying to explain what is the Veda, the kind of expressions that he uses is interesting. So, Sri Aurobindo writes that the Veda is a book of esoteric symbols. So, you see this idea of symbol, I mean this is ingrained in the Indian mind, because Veda forms a foundation of the Indian culture as we know it, almost of spiritual formulae. So, Vedas are like a book of formulae which masks itself as a collection of ritual poems. So, Veda is very symbolic, like something like Agni. Agni is a symbol for aspiration. So, in the spiritual journey, the first thing that you need is aspiration. So, how do you represent it? It is represented as an Agni which is soaring very high. That is why the Vedic Veda starts with Agni Mile, and that is why these Vedic fire altars, it is with the falcon bird, because the falcon is something which soars high. So, first thing you need is aspiration. So, you see that what he is saying is, out of the sameness of experience and out of the impersonality of the knowledge received, there arose a fixed body of conceptions constantly repeated and a fixed symbolic language. So, Veda is something which is written in a symbolic language, which perhaps in that early human speech was the inevitable form of these conceptions, because alone capable by its combined concreteness and power of mystic suggestion, now comes a crucial phrase, expressing that which for the ordinary mind of the race was inexpressible. So, you have something, some mystic truths which you have to go to a higher consciousness to reach it. But to people who do not have that, how do you represent that? How do you represent that which is inexpressible in the human language? Express it through symbols. And what is algebra about? You do not know something, you are seeking it. So, that has to be represented symbolically. So, that which is inexpressible, you express in symbol. This is ingrained in the Indian thought process, Indian culture. So, no pursuit of aesthetic grace, richness or beauty induces these mystic poets to vary the consecrated form which had become for them. So, once a symbol, once something is used for a certain thing, it is not going to be different, like cow, go, that always represents knowledge, illumination. Ashwa represents force, energy, etc. And now, nowhere will cow will be used for force. Hound is used for intuition, because the dogs have strong intuition which straight away arrives at the truth without factoring through reasoning and logic. So, intuition is called sarama. Now, so these things will not be changed. So, this was for them a sort of divine algebra, transmitting the eternal formulae of the knowledge to the continuous succession of the internet. So, Sri Aurobindo uses the word divine algebra for the Vedas. So, there is something algebraic about the Vedas. Okay. So, since the mathematicians grew up in an environment where Vedas was in the air, that could have or that was conducive, let me put it this way, that or might have been conducive for the invention of algebra in the sense of representing symbolically that which is unknown. Vedas is also not about the unknown, it is like about expressing the unknowable. The unknowable is expressed through this divine algebra, and these mathematicians expressed unknown through the algebra as we know it. A parallel is there, that the use of symbols in early spiritual treatises to express that which is unmanifested to the seeker, to express subtle truth intangible to the ordinary mind, and use of symbols in later technical treatises to express the unknown quantity which is being sought. So, in support of my speculation, I will give you one word, Ishta. What does Ishta mean? That which is sought. And most often in Indian literature, it is used for Ishta Devata, chosen deity whose realization is a seeker's aim. So, the seeker is looking for the Ishta Devata. What is interesting is, what was the Indian term or one of the Indian terms for the unknown? It is Ishta. Used in mathematics, Ishta is one of the terms for unknown or variable. Brahmagupta's that Bhavna starts with Mulam Didha Ishta Vargad. That means x1 square and x2 squares, they are called Ishta Vargad, Ishta. So, Ishta is the term for the unknown. So, this is something which is I would say that I am kind of thinking aloud, that whether the mystic culture had helped in the emergence of algebra as we know it in India. So, thank you.